Welcome back to my Unreal Engine 5 C++ tutorial on building a Tetris-Like. Alright, so last time we created child blueprint classes of block base for each of the different type of tetraminnow, and we added the mesh to the corresponding tetraminnow to it. Now, time to work on the tetraminnows themselves. So let's go back into C++ classes, go back into public, we'll create a new actor. Next, and then we'll call this tetraminnow base. Get the class. All right, and we don't need all these blocks open anymore. Don't need the HUD, don't need the box, need the widgets. All right, fantastic. So let's take a look over at the old Cubamino project. And we want to take, not the header files, well, we will need the header files. We need tetraminnow base and tetraminnow base.h. In this video, we're just gonna go through all these attributes and, well, maybe not all of them, but we're gonna need blocks. We're also gonna need, oh yeah, okay. So then we also need a T subclass of block base. That's because we're going to be generating the blocks from block bases, and then we'll take the actual. Well, that's about it. Actually, we basically just have like orientations, buffers. All the tetraminnow class is even doing is holding a position for each of the blocks contained in the tetraminnow. At least that's how I'm setting this up. So yeah, let me look at the constructor here. Block positions. We're setting it up in a 3x3 grid. So that's what we'll do for now. We'll take block positions. Where is it? My eyes aren't even seeing it. Block positions. There it is. It's a T array of vectors. All right, so we're taking T array block positions. Grab that. Go over here. That, yeah, should be protected. Throw that in. I'm gonna take out all this comment shit that we don't need. Block positions. Fantastic. That is not a U property, so we're not actually using it. While we're at it, let's, you know what, we'll take the orientation as well, because we are going to need that. Oh, it would help if I was actually in the C++. Drop that in here. Delete that line, and then we'll move over orientation. And oh, that I did make a visible U property. That's just for debugging purposes. I'll probably remove this U property eventually. But I just want to be able to see in the editor what the orientation is and see if it matches what I'm seeing in the screen. All right, so we did the orientation. We're setting up the block positions. And then we need the T array of blocks. Okay, and then need the T subclass of block base. Which reminds me, let's go up here and forward declare these. So class block base. I think that's the only one I'm going to need to forward declare. F vector is going to be built into the engine. I can't remember if we're going to need to tick in this. I think we might. I'll leave it for now. When I go through like an optimization pass, I'll check and see if I need to tick for all these things. Okay, so we have block positions, orientation. We have block positions, the blocks themselves, and the orientation. All right, so let's compile this. Make sure we didn't make any mistakes. Oh, and before I compile, I already remembered I need block base.h. Actually, let's go to block base CPP so we can copy it exactly. Block base CPP. This, go into Tetramino base, paste that in here. Now it should compile. Actually, it probably would have before since we forward declared that. But when we actually use the blocks and generate them, we're going to need them here. Okay, perfect. So we are indeed compiling. Why I have this open. Okay, so what I'm going to do next is I'm going to place the blocks and move over the actual code itself. But in order to visualize this, I'm going to drag out the 7 different tetraminos here. Actually, no, I have to create the subclasses of these tetramino base. All right, so let's go through. Go create C++ derived from, and what did I call these? Let's keep it consistent so that it's kind of easy. Yeah, so I just named them like tetramino I, J, L. Okay, that's fine. So we'll start with I. Tetramino underscore I. Create class. Okay, and I'm going to do this. Let's talk in the layout. I'm going to do this 6 more times for each of the types of tetraminos. So I, O, J, L, S, Z, T. That's all of them. So when I finish that, I'll be right back. Okay, we should now have 7 tetraminos, 1 for each type of tetramino, derived from block base, and an equivalent C++ should be generated over here. So now we still have block base, but the next thing that we need, or tetramino base, the next thing that we need to do is actually set the block positions. So let's go look at the code for the other group that we're migrating. Set block positions, I think is what I called it. Let's look in the base. Set block position. So this is going to be blank in tetramino base, but this is where it's going to be different for each of the each tetramino below it. So let's go back into regular one. I'm going to go virtual because we're going to be overriding it. Virtual void set block positions. Actually, I don't know if I need the override specifier here, but it will need it in each of the ones below it. And let's just copy it, make sure that it fits exactly what we had it set as before. Tetramino base base.h. Yeah, it was not an override because it's not overriding it from a parent. Okie doke. Let's go over here, right click, and create declaration, definition, and just leave it blank. Now for each of these, Tetramino I.h, we're gonna need protected void set block positions override. Let's see if that compiles. I don't think I need the virtual keyword if it's not going to be overridden. Let's pause the recording while this goes. Oh, it gave me unresolved externals, but I think that's because I didn't actually create the declaration in Tetramino I. Let's do that, and then we'll build again. All right, so that did indeed compile once I added that. So the next thing that I'm going to need is a begin play. So void begin play float delta time, or is it delta time? Override. Let's check that in the Cubamino project. Oh, begin play doesn't have delta time. What am I thinking? Okay, so we'll start working on the eyepiece. What makes this one unique is it does indeed change what the block positions are. So it's a little different from the rest of them. It's not a 3x3 grid. So take a look at these, take note. I'm just going to copy them, move them over. Okay, and I didn't have this apparently in my. Oh wait, no, I don't need a call to the super constructor. I don't know that I need this. Block positions empty. I very well might not, since I'm not calling to the super constructor. That I'm not certain about. Oh, that's in begin play. I'm in the constructor right now. There we go. Yeah, so I did call begin play first. I must have removed it over here. Oh, let me make sure that I'm in the right project. No, I was not. So call super begin play. Now, if I left this off, I probably wouldn't need to do block positions dot empty. So we'll try that for now. Just save a tiny bit of performance. I don't think it's going to yell at me for not calling the parent begin play. I am ticking. All right. And while that is building, yeah, that finished, no errors. So set block positions is the next thing we need to do. We'll copy this. Take a look at what it's actually doing here. But I'm taking the block positions that I have up here, and in 0 and 2 orientations, it's going to alternate between the down and up position. So yeah, block positions plus get actor location. That is because it needs to take into account where this particular tetraminnow is, and then set the location of the blocks that it's actually doing. And I could probably use set relative location actually, because I think it would still set the world position, but that's not how I was doing it. So I'll do it the same way that I was doing it here. Let's paste these in. Begin play, set block positions, begin play, set block positions. Yep, all right. I was just making sure that they were in the proper order. So let's build this again. No, oh, that's right. I didn't create the blocks. So there might be something else I need to migrate, probably in Tetraminnow base. I think I need to add the blocks up here. Maybe not. Doesn't look like I'm doing that in Tetraminnow base. But there is one more thing I need to migrate, and that is the creation of the blocks themselves. So I'll be right back. I'll explain that once I get through it. Okay, so the problem was I did not have my include block base up here. For a minute, I thought that since I have block base included in Tetraminnow base, that it would inherit it down. But I did forget that I'm doing forward declaration here. If you're not familiar with forward declaration, it's basically just a way to keep your headers clean and then only add. So if anything were to inherit from this, and I just say I need like a block base, I don't want a whole bunch of headers that I don't need in here. So you forward declare to clear the error, and then you only add the headers that you need from anything that might be including this header. It can have an issue of like exponentially increasing the amount of like code and header files and stuff. Now, I believe Unreal Engine has like protection against duplicate header files. But the more like compounded header files you have, the longer it is going to take to compile. So keep that in mind. That is why I forward declare, and that is why it did not get the Tetraminnow or the block base from Tetraminnow base, even though I have the header for Tetraminnow base in here. Base, yeah, block base. So it's included. I built, so everything is good to go. Let's compile. Or well, kick off live coding. This might take a minute because I changed a lot of things. Oh no, that wasn't too bad. Okay, so we were working on I. Now we need to create a blueprint. Call it BP underscore. The wrong button. Tetraminnow I. Stick it in blueprints and actors. Create blueprint class. Okay, so BP block base. This is actually a T subclass of. So I have the option to stick in the blueprints that I created previously, so it'll have the correct meshes. So BPI, very important to make sure that we do this. And then the blocks. I don't think I actually generated these yet. Let's compile. Okay, so we don't need these anymore. That was just for a screenshot. Go into actors, BP Tetraminnow I. That's it. world origin. Now, when I hit play, I don't think this will generate any blocks yet. Yeah, we got nothing right now. So we still need to migrate over the code where we actually create the blocks themselves. I need to familiarize myself with where I did that. So I'll be right back. Ah, here it is. Okay, so we didn't migrate over begin play from Tetramino base. So let's grab super begin play all the way through here. All we're doing is spawning an actor of the T subclass of that is declared in our header file. So get world, spawn actor, block base, and then get actor location, get actor rotation. So that'll do that 4 times, loop through 4 times. We'll make sure that the orientation is 0. And then for them to actually show up in those positions, we need to set block position. All right, so heading back over here, we'll go to Tetramino base, begin play. Shouldn't have grabbed begin play back there. Delete this, recompile. Wonderful, head back over here, live code. Finished, way, save. Okay, so I would think that the Tetramino, the eyepiece will show up now. No, it has not. All right, one moment while I investigate why. Okay, so I think we're having some editor related issues here. So I closed the editor, I recompiled, and when I came back in, all of my C++ classes are gone, but they still exist in my actual project. So when things like this happen, what I like to do is close out all of this. No, I don't want that to reopen. We're in our TetraCube folder. Then I'll delete saved, intermediate, binaries, VS Code, and the workspace. Delete all of them, and then right click, go more options, generate Visual Studio files. And this usually fixes that issue where the editor isn't picking up the C++ classes. So when this finishes, I'm going to open up the workspace again, recompile, and then I'm going to open up my TetraCube project. It'll ask me to rebuild. I'll do that. So I'll do that off camera. I'll be right back. And while I was in here, I figured out what my problem was, why the blocks weren't spawning. It is because in Tetramino base, that is where I am actually generating the blocks. So I need to do that there, set the block positions. That happens in Tetramino base. And then I want to overwrite the block positions that I had. So that's why I was calling empty in the other one. So I wasn't wrong back then. Wasn't doing something inefficiently. All right, so super begin play. Thought IntelliSense was going to save me there. Begin play. All right, let's build again. Should go much quicker though. All right, fantastic. And now back to the editor. Double click this. I would like to rebuild. This might take a moment, so I'll come back when it's finished. Okay, it's a good sign. I can see my C++ files again. Let's go back up to blueprints, actors, terminal I. Double click this. Okay, so BPI is still in there. Excellent. And now we're calling begin play properly. So, where's the world origin? Okay, so it should appear right above those things. Close out the content browser. Play. Oh, did I copy the wrong? Oh, okay. So it looks like I copied the wrong block set block positions. So I need to go back and fix that. I'll be right back. Okay, I see what the problem was. So in Tetramino base, when begin play runs, it has all of everything is in the constructor. And then when begin play goes, it sets the orientation and set block's position. But down here, I had all this set up in begin play. I did not have it set up in a, I need a public void. Oops. Copy. Termino I. Oh, and we do that. Come on. I guess we'll just copy it from over here then. Not sure why it's not. All right, so, oh, it doesn't need a void. I forgot about that. Go back over to TetraCube. Go to the header. We don't need a void. The constructor. Now will it work? No, it will not. So we're back in Cubomino. Tetramino I. Put this in the constructor where it's supposed to be. Back over to TetraCube. This will be before begin play. And now, when begin play is called, it'll call up to super. It will generate the blocks, set the orientation, and then set the block positions. So this should work now. We just didn't have the constructor set up. All right, had it all in begin play. All right, finish building. Off live coding. Huzzah, there we go. All right, and then the next thing I want to do, actually, remember if I made orientation edit anywhere. Orientation, no, I did not. But let's test the other orientation. So we'll go up into block base. Actually, you know what? We'll just change it and begin play. Orientation equals 1. Build again. Oh, we need to set block positions, damn it. Build yet again. Could probably just go over here and hit live coding. As I learned in a previous video. All right, so it should be up and down now. Yep, perfect. Wonderful. All right, so I'm going to go through and do this for the rest of the Tetra Minnows. I'm going to copy everything over from the Cubo Minnow project that we're migrating. I will hurry up and I will click through each of the set block positions for all of those. I think most of them have the standard 3x3 grid. I'm pretty sure the only one that doesn't is the eyepiece. So let's look at that. So, Tetramino J. Oh, that's the header. Here's the block positions for J, L. Oh, all of this is pressed. We are ticking here, but I don't think we need to. All right, but there's there's L, O. All the orientations. Click this, make sure it stays open. S. T. Z. I think that covers everything. IJLOSTZ. All right, well, I'm going to get these moved over. I might actually test out if set relative location works here. I'll do that too, but I'll come back when I finish setting these orientations and we'll wrap up. Okay, so once you have all the set block position code migrated over, the other thing I did is I don't think the Tetramino needs to tick, so I turned off tick for all of those, at least for now. The other thing I did off camera was I moved blockbase.h into the header of Tetramino base. Just because it made things much easier, and anything that inherits from it, it's going to need block base. So that's fine. It just saved me some copy pasting. That's about it. So once all that code was migrated from C++, I went through each of these and I made a corresponding blueprint. And in those blueprints, I set the block base to the type of block that it is, so it would have the correct color. And I placed them all in the scene. So we should see one of every Tetramino when I hit play. Perfect. All right, so that's going to wrap it up for this video. I hope you enjoyed it. See you in the next one.